Okay, so we're going to look at number 18. In number 18, they give us a photoelectron spectrum, a PES. They say it's of neon, and they want to know some questions about it. The background on this is, remember that these peaks correspond to where electrons are in neon. So it might be a good idea for us to get clear on what the electron configuration looks like for neon. So remember to obey Hund's rule, and then there you go. So these electrons are the 1s2 electrons, then these are the 2s2 electrons, right? And then these are the 2p6 electrons, so it's full. It has a full octet. So the binding energy represents that, the ones that have very high binding energy. And you notice the scale is backwards here, but these are very high binding energy down here. Well, that must be the electrons that are located really close to the nucleus. That's why they have high binding energy. B, I think these have the next highest binding energy, and you can see those would represent the electrons in the 2p orbital. So these are 6 electrons, 2 electrons, and then 2 electrons, and that's why peak C is taller. So based on an idea that the electrons here are the 1s2, it might be good to label that, the 1s electrons, the 2s electrons, and the 2p electrons, let's look at the questions. Peaks A, B, and C represent the binding energy of electrons in which sublevels? And I think they mean respectively, as in that order. Well, we've already answered that. A is the 1s, B is the 2s, and C is the 2p. So I think the first answer should be good. If we look at B, which of the following statements best accounts for peak A being far to the left of peaks B and C? So they're saying, why does this one have so much higher binding energy? Well, a lot of these answers might be true, but we're looking for an explanation of why this one has much higher binding energy. So I think I would look at, well, peaks. Let's look at the first one. Peaks B and C show first ionization energies of electrons in neon, whereas peak A shows the second ionization energy. Nope, that's not true. These all are first ionization energy peaks. In the second one, neon has 8 electrons located in its valence shell. That's flat out not true, by the way. We know that, well, actually, no, it is true. There are 6 electrons in the second energy level, right, which we could also find here. 1, 2, 3, 4, 5, 6, 7, 8. So that one's true, but it's not the correct answer. So B's out, or the second one's out. And then core electrons of an atom experience a much higher effective nuclear charge than valence electrons. That one is sounding good to me. The core electrons experience much higher effective nuclear charge from the nucleus. I think that that third one's the answer. The last one, by the way, is true, but it doesn't explain why this peak is much further to the left than those peaks. So a couple of true answers there, but the third one is your best choice. And then we get down to C. Which of the following statements best accounts for peak C being 3 times the height of peak B? Well, as we already established, the height of the peak has to do with how many electrons are in that orbital, and so there are 6 electrons. So if we look at the answers, the intensity of the photoelectron spectrum at a given energy is a measure of the number of electrons in that energy. Ooh, that sounds good. I think that might be the answer. Electrons represented by peak B have approximately tripled the binding energy. No, that's not true. We know that taller peak doesn't mean more binding energy. Left and right means more or less binding energy. Yeah, I think the first one's going to be the correct answer. Now with all of these, don't forget to go down and do your corrections and notes.